Hello class and welcome to part 3 of this topic, and in this part 3 we're going to talk about boiling and condensation. So what is boiling? We define boiling as a process whereby the energy transfer changes the state of a substance from liquid to gas, and very importantly also at constant temperature. For pure substances, boiling occurs at a constant temperature called boiling point. So these are some of the examples of the boiling points of several substances that you can find on Earth. As you can see, hydrogen gas has a very low boiling point, minus 253 degrees Celsius. Alcohol, on the other hand, has a boiling point of 79 degrees Celsius. That means alcohol changes into gas at 79 degrees Celsius. Whereas mercury, you need a high temperature in order to turn mercury into gas. Now, this is what the heating curve of a boiling substance looks like. And this heating curve shows you all the way from when the substance is solid up until when the substance boils or turn into gas. So you can see in the beginning, the substance is solid. And then for this first horizontal line here, the substance undergoes melting. And then after everything has been melted at this point, everything now becomes a liquid. The temperature rises up until when it reaches boiling point here and the substance boils. Once everything has become gas, then the temperature continues to rise. Okay, so this is what typically the heating curve of a boiling substance looks like. Condensation is just the reverse process of boiling, and this is the definition for condensation. The definition reads, it is a process whereby the energy transfer changes the state of the substance from gas to liquid, and again at constant temperature. So condensation occurs at a constant temperature, and this constant temperature is called the condensation point. Note that the condensation point and the boiling point are basically the same temperature. For example, water has a boiling point of 100 degrees Celsius, and water also has a condensation point of 100 degrees Celsius. Now, if you draw a graph of temperature against time for substances that are undergoing condensation, it looks like this. So this is the cooling curve. So you can see the substance starts as a gas and then reaches the condensation point, and this is when the substance is converting or changing state into liquid. So at this point here, everything becomes liquid, and then the temperature continues going down, and then it reaches its freezing point. Everything is starting to freeze, and then at this point here, the freezing has completed, and then the temperature continue going down, and at that point, the substance is a solid. Now let's do example 3 to show you how we can sketch a heating curve. So the example reads, given that a substance X has a melting point of 0 degrees Celsius and a boiling point of 75 degrees Celsius, if we heat up a substance X from minus 10 degrees Celsius to 100 degrees Celsius, sketch its heating curve. So let's quickly sketch this curve. And for the y-axis, this is temperature with the unit degree Celsius, and for the x-axis it is time with the unit second. So the substance start at minus 10 degrees Celsius, and then it has a melting point of 0 degrees Celsius here, and also a boiling point of 75 degrees Celsius. Now we have to draw what the heating curve looks like. The substance starts at minus 10 degrees Celsius. The temperature rises, and then when it reaches its melting point, the temperature is constant. And then once everything has done melting, it rises again, and then it reaches its boiling point, which is here. And then once everything has ended, the temperature will rise again. So this is what the heating curve should look like. Let's do this other example. For the same substance, show a cooling curve where X is cooled from 90 degrees Celsius to minus 15 degrees Celsius. So let's draw a graph really quickly. So this is what the graph looks like. Let's note down where the melting point is. The melting point is 0 degrees Celsius and also 75 degrees Celsius. That's for the boiling point. Now let's draw the curve now. The substance starts 90 degrees Celsius as a gas, and then temperature decreases when the substance reaches its boiling point, or in this case, it's cooling down. So it's the reverse. It is actually doing condensation. So 75 degrees is the condensation point. The temperature becomes constant. And then after that, the temperature goes down again. And then it reaches its melting point, or in this case, its freezing point. And then the temperature becomes constant again. And then once that is done, it then reaches to the final temperature, which is minus 50 degrees Celsius. And this is what the cooling curve looks like for substance X. Now, just like melting point, boiling point can be affected by other factors as well. The first one is impurities. So, if you add impurities to pure substances, it can increase the substance boiling point. For example, if you put salt into normal water, that will increase the boiling point of normal water. If the normal water has a boiling point of 100 degrees Celsius, if you add salt, the boiling point will increase a bit, maybe to around now it becomes 102 degrees Celsius, something like that. The second factor that affects the boiling point is the pressure. So if you lower the pressure, you will decrease the boiling point. If you increase the pressure, you will increase the boiling point. As an example of this, if you go to the top of the Mount Everest, as you know, the higher you are from the sea level, the less atmospheric pressure that you will feel. Now, because the atmospheric pressure is very low, the boiling point of water there has decreased, and it is now to 70 degrees Celsius. So you don't really need a very high temperature to boil water when you're up on a mountain. The next part of this topic is part 4, and in this part, we're going to talk about evaporation.